So starting on this page, I found a formula from a British plumbing website. You know, I end up in the weirdest places sometimes. The formula says Q equals the square root of d to the fifth h over 25L times 10 to the fifth. And what I like about this formula, I'm going to go through and I'm going to show you how I do these. If I've got a lot of things floating around, I color code everything. So I look through and I scan the formula. So I've got a Q, then I highlight what Q is. Q is the discharge in the pipe in liters per second. That makes sense for a plumbing journal. And we know Q, we want to find Q. So that's what we're after in this whole big shenanigans here. The next letter I see here, D. D is the diameter of the pipe in millimeters. And we know the diameter is 15 millimeters. H is the head of the water in meters. You would have to talk to a plumber about this. I am not a plumber. But apparently it's a thing. I've seen it in a couple different plumbing areas. And let's make L. L is the total length of pipe in meters. And the pipe is 8.62 meters. And part of the reason I want to do this one is because what you notice about this formula is it takes in things of different dimensions and outputs it in liters per second. So the formula itself is doing the unit conversions for you, which is pretty awesome. So if I wanted to do this, I'm going to have Q equals the square root. D is blue, that's 15 to the fifth. H is green, that's 1.2. You could do the 1.2 or 1.20, either one will work. Then the 25 is static, that doesn't change. L is 8.62 and times 10 to the fifth. Now what I did is I just multiplied out the top and bottom. Typing all of this in my calculator would probably be a nightmare. So I times the top stuff out and got my answer. And times the bottom part out. And then did the square root of that fraction, and it came out to be about 0.21 liters per second. So under the conditions that we were given, the water coming out of the pipe is going to come out about 0.2 or 0.21 liters per second. This is just a plug and chug problem, but it had a lot going on. And that's why I tend to color code things while I do this. You guys are welcome to bring highlighters, colored pencils, whatever it is you want, if you feel you need to organize things in this way. For me, it's the easiest way to handle things on my end, but you might be able to process things a little bit differently, so whatever works for you would be the best thing for you. The next three problems that we have are different in that they are open-ended questions. We don't know the answers. We're trying to do our best estimate as to what's going on here. So the first one, suppose you got really rich one day, and you went to a Ravens game and you wanted to buy everyone there a beer and a pretzel. So the question is, how much would that cost? So when you do these estimate problems, you have to make some assumptions. And I'm not going to be able to ask you anything too off the wall on something like this on a test, because I can't assume that you've ever seen a Ravens game, so that you would be able to estimate how many people are there, or that you've ever been to a professional sports game, so you would be able to estimate the cost of something that's being sold there. These ones I picked because they're things that are pretty common, but it's still, you have to have a little bit more experience than just maybe some of you do. So these are very specific. I would be a little bit more wide open on a test. We'll talk about that more in class next time. So assumptions that we would have to do. To solve the problem, we need to multiply the number of people times how much money it costs to buy these things. So if we think about the number of people at a professional football game, I would say, so a baseball game, baseball stadiums usually are built to fit 40,000, maybe 50. Football stadiums are quite a bit bigger, so I'm going to estimate that they hold about 70,000 people. And that, of course, that the Ravens pull in 70,000 each game. I've been to baseball games. I know beer is not cheap at baseball games. I hate beer, but I still know how much it costs at a game. So at baseball, it's about $9 each. And a nice soft pretzel at a baseball game. If you get the cheesy one, not cheesy as in cheese on them, but if you get the ones that are just the reheated ones, they're about $5. They had fancier ones. My husband got a fancier one last time we were at a baseball game. Those were a bit, maybe like $10. So I averaged them and said maybe they're about $7. So if we go over to how we were going to solve this, the number of people was 70,000. The total cost in dollars was 16 to buy both items. And when we multiply, we get dollars, 120,000. So about a little over $1 million to go ahead and do this. So if you come into a lot of money, this is a good way to make friends. But it's going to cost you a bit. The next one is one that vexes me every time I come into the STEM building. On the first floor of the STEM building, when you walk in the doors and go past the elevator, there's 4 panel TVs. Those TVs are generally on 24/7, 365. So my problem with that is that they waste a lot of money. So what I wanted to do was figure out about how much it costs to run those TVs for a year.